all online students. I hope I'm audible to you everyone properly.
Yes, ma'am.
Okay, so let's start with the session. Yes, everyone here, offline students now here. Can anybody tell me what we discussed last time? We started with unit number 3, right? Where we discussed relational algebra. Anything else we discussed? We discussed 3 to 4 things. We started with query language, and we discussed that query language is a language used to communicate with the DBMS. Then we also discussed there are two types of query language. One is there are two types of query language. Yes, correct, Prachi. So how many types of query language we are having? I hope you are not having RAM in your memory. Lecture पूरा था એટલે ભૂલી જવા.
Procedural and non-procedural.
Yes, correct. Procedural and non-procedural, where we discuss that procedural language is a language which says what to do and how to do, right? And non-procedural is the language which says only what to do. How to do is not mentioned there. So relational algebra is actually telling us what to do and how to do. SQL is the example of procedural language which is based on your relational algebra. Am I clear? This was the thing we discussed. Then we moved on to relational algebra concept where we discussed that. Let me open that for you. I think you will be... we discussed that relational algebra is the mathematics for your query, where you are having input, operation and the output. What is input? What will be the input in relational algebra? What will be the inputs in relational algebra? On what we work? Tables, correct. We work on the table. So our inputs is a table. It can be one table, it can be many tables, two tables. Because relational algebra has an operator of only two types, unary and binary. Either the operator will take one table as an input, either the operator will take two tables as an input. We have only two types of operators. So it is something like 4 plus 5 is equal to 9. That means 4 and 5 are operands. If we do the analogy, these two are your tables. Operator is any relational algebra operators like select, project, join, union, intersection. We'll see that. And then the result will be based on the table and based on the operation we perform on the table, the result again will be a table. Because if you add 4 plus 5, your result will also be integer. When you are adding two integers, your result will be integer. Similarly, when you are working on the table, your result will also be a table. But that table will be a unnamed table. Is it clear? So that was the things we discussed. Now we are supposed to start with the operators of the relational algebra. Shall we start? Right, today we have only one session, so I will be covering majority of the operations today, discussion part. Tomorrow we have two sessions, so we will use those operators with our expression. We'll do the examples so that we can continue with the example and majority of the discussion part can be over. So I request everyone, please attend this session very, very carefully because tomorrow we need all these things to perform the operations of relational algebra. Am I clear? Yes. So the operators which we are going to cover, are these many. Not all the things will be able to complete it today, but majority we will complete it. So these are your operations: select, that is selection operation; projection; cross product; division; rename; joins. You have different types of joins. You have set operators like union, intersection, or set difference or minus, and aggregate function. These all are there with your relational algebra. In detail, we are having in our syllabus. Now, you are all are familiar with selection. When we will be doing the example, you will say that yes, we know the selection, right? You have already performed an SQL operation, so you are familiar with the selection operation. Also, you are familiar with projection operation, right? We'll see it. Now, cross product. Rename also you know. What is renaming the table? I want to give another name. So rename is also known to you. Fine. Then this thing is known to you.
Ma'am,
Yes? Screen is
ma'am,
not
please
visible.
share this.
Oh, just a second. Now visible?
Yes, ma'am.
Okay. So these are the relational algebra operators. First two you know, rename you know, set operation you know. You all are familiar with set theory? Venn diagram and sets, and you are knowing that, right? So same concept of union. What is union? Taking from both the sets. If you have A is equal to 1, 2, 3 and B is equal to 2, 3, 4, then what will be the union? 1, 2, 3, 4. Similarly, intersection, A is equal to 1, 2, 3, B is equal to 2, 3, 4. 2, 3. Common in both. What is set difference or minus? A minus B. A is equal to 1, 2, 3, B is equal to 2, 3, 4. 1. Exactly. Whatever is there in A, but it should not be in B. Right? In A, not in B. Now, if I write A union B, can I write B union A? So, that is what? Which rule? Commutative rule. You have associativity and commutativity, right? So, that rule. Similarly, A intersection B, same as B intersection A? Right. A minus B, same as B minus A? No. Right? So, you all are familiar with that. The same thing will be applied here in the tables. And aggregate function also, some of them you are knowing. Aggregate function is the function which is working on a particular column. Let's say average is an aggregate function. It is combining the data and giving you some meaningful information. Average of your CPI, aggregate function. Summation of the marks, aggregate function, right? So we are having many aggregate functions because it is aggregating the data and giving you one value. That's why they are called aggregate function. Is it clear so far? Let's start with the most easiest and basic operation. Selection operation. The symbol, see, it's an algebra. That means it will be full of notations. As you have A plus B, so plus is a notation for addition. Similarly, selection, the notation is sigma. Sigma, not that summation sign, it's sigma. Which is this alphabet? Which type of alphabet it is? Greek alphabet, right? That is sigma. Notation is this. What is the syntax? Now, do remember the syntax here, this is sigma, this is sigma. Here you are supposed to write the condition in subscript. Condition in subscript of your sigma, we'll see it. And then the relation. Now, what is the use of this selection operation? Selection operation is used to retrieve the specific tuple from the relation. Specific tuple from the relation. That means what? You have performed the SQL query I want to retrieve a specific tuple. What I need? Specific tuple. Tuple means what? Row. So I want a specific row. Where? So your selection operation is similar to your where clause in SQL. So sigma retrieve me the tuple based on the condition from this relation. If I have the student table with student ID, name and branch, I need all the records of the student who is studying in computer engineering branch. So sigma branch is equal to computer engineering and relation is student. Am I clear? We will see that. But what the role of selection? Please do remember this. I need this thing tomorrow when we will be performing the exam. So selection is similar to your where clause in SQL. Analogy करो तो जी याद रहेगा. Otherwise, તમને શું રાઈટ સિલેક્શન છે એટલે શું આવે? Select something from student. એટલે select SQL નું આ select same છે. No. This selection is actually the where condition you are putting it in the select query, because we need some condition to retrieve a row. We have already understood that every column has a unique identity, but every row does not have unique identity. Hence, we need some condition to retrieve a specific row, and that can be done with the help of where clause. Is it fine? Let's move on to the next one. Yes, and along with the condition which you are using, you can use all these operators as well. Let's say, for example, today only A batch did balance greater than or equal to 500. So balance, you can use greater than or equal to notation 500. Is it clear? All these relational operator you can use. Along with that, you can use and or operator. That is V and inverted V. What is that and or? No. No, union intersection છે જ નહીં હજી. And or. Logical operator, but have we discussed it in SQL? તો yes માં શું discuss કર્યું હતું? Yes, if I have multiple conditions, what I do? Where condition 1 is equal to value 1 and condition 2 is equal to value 2. That means what will happen? If both these two conditions will be true, then and then only your entire where clause will be true. And means both the conditions should be true, or means any one can be true. Your data will be retrieved. So same thing, balance is less than 500 and account number is A001. So I am combining two conditions in your condition in select query. So you can use two types of operators along in the condition. A relation operator, less than, greater than, equal to, not equal to, like that. And along with that, you can also use your logical operator and or. Am I clear with this? This is the example given to you how you are supposed to write. Select branch is equal to verse where from the table deposit. So it will retrieve all the record where branch name is verse. Am I clear? Branch name is this. Let's say for branch name is equal to this and account balance greater than 1 lakh. So I have to use that and operator. So here only I will be writing, here in the subscript only I will be writing branch name equal to A and amount is equal to amount greater than 1 lakh. Is it clear? And here you are supposed to write the relation on which you want to fire the selection operation. One thing to remember here is your selection operation is a unary operation. Unary means it is going to take only one relation, right? We will see later on that there are some operators we will take two tables as an input. It is very similar to your unary operator called unary operator? Increment, decrement, plus and minus. It takes only one argument, one operand. Similarly, your selection operation also takes one relation only. Is it clear? So it can retrieve the tuple from one relation only at a time. Shall I proceed? Got the concept? Similar to your where clause in SQL. Okay, let's proceed then. So find out all the records where A is equal to B and D is greater than 5. So A, B, C, D, this is your attributes, column headers, this is the data, alpha, beta, some random data. Now output will be C. You have merged two conditions. A is equal to B and D is greater than 5. On which relation? R. Clear? So you can see the output. You can see the output. It will only retrieve the tuple where A and B are same. Also, D is greater than 5. So this row will not be used, beta wala. क्योंकि इसमें D की value क्या है? Less than 5. Right? So that will not be taken because as it is an AND operator, both the conditions should be true. Clear? Okay. The example we'll see, practical example we'll see later on. Next comes projection. This is also you know. Have you used that? It is very, very similar, or it is same as your select query. Select query does what? Select account number from column. What you are doing? Your select query is going to select the particular column. Can be one, can be many, can be all. Right? Select star from table. Select account number, comma, balance from account. That means you are selecting few columns from the table. So projection operator is actually projecting few columns from the relation. So if you want to retrieve the entire column, we use projection. That means if we want to filter at column level, we use projection. If we want to filter at row level, we use selection. Clear? Same as if you want to filter at column level, what we write? Select something from student. Then entire tuple will be, entire column will be retrieved. Right? But if I want to filter at row level, we were using where clause. So if I want to select some of the columns, I will be using projection. Notation is pi. Notation is pi. So pi, list of the attributes, list of the column names if you want from the table, and the relation. Clear? Now, and the attribute list will be separated by comma. Account number, comma, name, comma, city, comma, branch, like that. Fine? Select specified attributes of a relation. Entire column will be selected. The result of the projection operator has only the attributes specified in the attribute list and in the same order as they appear in the list. If you are projecting first account number and name in this query, account number, comma, name from relation, it is going to give you the output as account number and name. If your projection list is select a name account number from the relation, the projection will be first name and then account. Is it clear? Got it? Sure. Online students, are you with me? Getting the things?
Yes, ma'am.
Select.
Yes, ma'am.
These two are very,
Yes,
very fundamental operator which every query will be having. Rather, every relational algebraic expression will have. So it's it should be very much clear that if I want to retrieve the entire column, I will be using projection. If I want to retrieve few records, I will be using selection. Fine? Okay, great. So branch name, comma, amount from the deposit. This is the simple example. Projection symbol pi. Okay, so this is your student table. Some attributes are there. Display the enrollment number, name and city of all students. Right? So we will be writing pi enrollment number, name, comma, city from the student. Is it clear? Now you must observe this. You must observe this that here in the expression we are actually not having any kind of uh, English statement. Like in SQL, we are having select star from something, right? We are using many English terminologies. Here we are not using English terminology. We are not having a sentence form of a query. Instead, we are having a notation based query, right? Okay. Now this is interesting. Combine. Can we combine? Can we combine select and where? Can we combine? Similarly, we can combine selection and projection. I want the student name who is in the computer engineering branch. So I am not interested in all the details of student. I am interested only in student name. So I will only project student name. And I have a condition also that the student should be from the branch computer engineering. Am I clear? So I am having condition as well as I am having the projection. So at that time you are supposed to apply to. How you can apply? Pi enrollment number, name, comma, city. Oh, this is okay, fine. This is this example. From this table, I want only 3 columns where branch is equal to IT, where branch is equal to CE. So what I did, this part is called the inner part or inner query. This is your inner query and this is your outer query. Correct? Obviously, which will be execute first? Inner, of course inner. If you have 4 plus 5 into 3 is equal to what? What will be evaluated first? The inner bracket, right? Similarly, when you are having inner queries, haji ani पण एक अंदर होत तो, so that will be evaluated. So your innermost query will be evaluated. The temporary output. Now this will generate some output. Yes or no? This will generate some temporary output. Based on that output, the outer query will work. Obviously, is it clear? 4 plus 5 into bracket 3 minus 2. So first of all 3 minus 2, 1. So intermediate result is 1. Then that intermediate result is added to 4. The same way, branch is equal to IT will be filtered first. Then that temporary table will be created. You will not be able to visualize the temporary table, right? Anyways, one thing to remember, you cannot directly implement this algebraic expression with your DBMS because this is a concept, right? This is a concept and on this concept your SQL is created. Fine. So if you want to interact with the database, you need a language. This is a concept on which, this is a mathematical model on which your language has been formed. So don't ever think कि मैम ये मैं लिखूँ कैसे? Apex में how to write this? You cannot write this. Base, if you want to apply this, you need one SQL, you need one query language which will implement this thing and will work for you. Don't ever assume. Sometimes you will feel that, madam, yeah, so if we implement it, we will not get the things. But anyways, you are not going to implement it directly. Clear? This is a mathematical concept, a base for something, and that something is your query language. So your inner query. Now one very interesting and logical thing, if you have understood everything properly in SQL and here, you will be able to know. Can I interchange these two operations? Can I apply first projection? Are you getting what I want to say? Can I write sigma branch is equal to IT inside bracket project name and student? Can I do that? See, either answer will be yes or no. There is no other answer.
No, ma'am.
Online student, you can do or not?
No.
Why yes and why no? How many of you says yes, you can do? Okay, fine. See, anyways, if you have some opinion, it might be wrong. That's fine. We are learning. Everything is new to you. That's fine if you are wrong. But have an opinion always. That proves that you are actually working. It may happen that your thinking is in wrong direction, but that's fine. So yes, some of you are saying yes. How many of you says no? You have to be in one group. કારણ કે partially આનો કોઈ આન્સર જ નથી કે partially થાય, કોકવાર થાય કોકવાર ના થાય, એવું ના હોય. Either it will be yes. So majority of you are saying no. Can you justify why no and why yes? ઓકે, યસ વાળા જયદીપ બોલો, શું કામ થઈ શકે? Okay, fine. Now let me explain what happened. That's why only I told you the concept of inner query. Right. Whatever is at inner part, that will be executed first. That you are agreed, right? Let me take this condition first. I am not saying which is the correct answer right now, but you need this, you need to understand this very much properly. Let us take this condition only right now. I am applying selection first and then projection. So what will be retrieved here? It will retrieve all the rows which is having branch IT. It will retrieve all the rows, entire row having branch IT. Am I clear? From that intermediate result, I don't want the entire row data. I want only 3 attributes to be displayed. So from that entire 5 columns, from entire 6 columns, only 3 columns are projected and visual and given as an output. Is it clear? Let's understand the second case. If I am projecting columns first, what will happen? Select enrollment number, name and city. Enrollment number, name and city from the table. So in the intermediate table, I have only 3 columns: name, enrollment number and city. Now I have to apply the condition branch is equal to IT. Do my intermediate table have the branch IT? No. So how can I retrieve it? So moral of the story is, whenever you are having selection and projection together to be applied, always apply selection first. Based on the selected rows, just project the columns which you need. Am I clear? In some case it may work where you are selecting something, you are projecting something, અહીંયા જે branch પણ project થઈ હોત તો possible થાત, right? But in every case it will not work, because see this example only, I am projecting partial table and that partial table is not having my condition column. So how can I select the appropriate record, right? So in some cases it may work, in majority of the cases it may not work. So what you have to remember, that whenever you are having selection and projection together to be applied, always apply selection first. That means your inner query should be of selection and the outer query should be of your projection. Is it clear? Ready? Justified?
Yes.
Fine. So that's what these 2 things. Okay, Cartesian product I'll do it later. Join will be doing later on. Union. I'm just discussing the things which is already known to you. Union. What is union? Again we know. Set theory concept only. Notation is also same. U relation 1, union relation 2, operation selects the tuple, those are in either or both of the relation. Am I clear? So your union operator is actually binary operator which takes two columns, two relations. Example समझी लो. समझे क्यों? You have in R table you have alpha, alpha, beta 1, 2, 1. In S you have alpha 2, beta 3. Now it will take all the tuples from A, all the tuples from B. Now total number of tuples in A are how many? 3. Total number of tuples in B are 2. So when you do the union, actually it should be 5, right? The thing is, as your relational algebra is based on the set theory concept, you know that in set duplicate values are not allowed. So when you are having duplicate tuples, your output will not show that. It will only show the single time, every tuple single time only. Is it clear? Fine. So alpha 2 is visible only one time. Union समझाई क्यों? Now, actually the union will be in this kind. You don't entirely union the things. We generally apply projection while doing union. मतलब मुझे ये टेबल में से हाँ ऐसा भी होता है मुझे पूरा का पूरा टेबल यूनियन करना है that also possible. But if you want some columns from A, some columns from B and then unite it, that also is possible. So I am just projecting one column from employee table, one column for customer table and then taking the union. Is it clear? So theoretically this is the concept, but practically this is the scenario. Can you give me the difference between theory and practical here? This is theoretical, where you are merging two things. Practical, your union, intersection and set difference should be applied logically. See, theoretically you can apply on any table, any two tables, but practically you should apply union, intersection and set theory on those tables only where you are having something common. That means you are having some compatibility between two tables. Is it clear? Then and then only it is the meaning of taking a union. Got it or not? Otherwise the meaning will not be there. Yes, theoretically તમે કોઈ પણ જે compatible નથી, you are having column A and B in you are having A and B in relation R and P and Q in relation S. No common things, still you can do union, that's fine. But practically it is not advisable to perform union when the two tables are not having anything in common. Is it clear? I am taking the union of the students who are in mechanical branch and computer branch. Is there any common thing between mechanical and computer? No. So I can do theoretically. I can combine these two class, but it makes no sense, right? Can I combine IT and computer? Yes, they are having many things common. So that is a meaningful union. Otherwise, theoretically, anything can be done. You can altogether write a logic which is not at all practical. Programming language or your query language will not say that you cannot write this, but you should not write this. Anything to explain here? It will take only those tuples which are in both. Again, do you agree with my statement? You should always do the interaction if there is something common. I am intersecting mechanical and computer. I'll be getting null set. There is nothing common. I am intersecting IT and computer. I'll be getting many subjects, which will be common. Fine. Display the name of the person who are employee as well as customer. Common. Clear? And here common does not mean common data. Common means common attributes. In both of them, we are having name as an attribute which is common. Is it clear? Let us do the last one today, and from tomorrow we'll be starting with the example of this all. As it is a minus, that is set difference, the notation is minus. Relation 1 minus relation 2 returns all the records from first query that are not contained in second. A minus B. All those things which are in A but not in B. A is equal to 1, 2, 3, B is equal to 2, 3, 4. My answer is 1. B minus A. A is equal to 1, 2, 3, B is equal to 2, 3, 4. 4. Samjhay example? Fine. So that's what the thing. So here manager and employee. What will be the answer? Manager minus employee. It should be, he should be a manager but not a employee. So Tirth and Hari both are in this table. So only the answer will be Jai. And here employee minus manager. It should be employee but not a manager. Then only Smith, because these two are common in both. Clear with this? Sure. So let's summarize the operators. Okay, we'll see it later. Fine. This all thing we will do. And next we'll be doing with cross product, Cartesian product next time. Right? Let us revise it. Online student, is it fine from my side? Selection, projection, union, intersection and difference. Great. Please do remember these things, some key points which we discussed, because tomorrow we'll be using the query. I'll be giving you the tables, I'll be giving you the query. You are supposed to tell me the algebraic expression for that. Okay? So please do revise and then attend the session tomorrow. Let's revise it. Fine. So same thing. So selection operation, it is a unary operator, need only one relation. It's a fundamental operator. What is fundamental operator? Do you know primitive type and derived type? What is derived data type? It is derived from the primitive type, right? For example, structure, union. These are derived data type because it is a collection of primitive data type. But your integer, float, character, these are primitive data type. Similarly, some operators in relational algebra are fundamental, that is primitive, whereas some are derived one, that can be derived with the help of primitive. Do you know that set theory में कदाच proof आवी होय तो your union and your set difference is a fundamental operator, whereas your intersection is a derived one. Do you know this? A intersection B is equal to, I don't have the notation, that's why I write A intersection B is equal to A minus do you know this? With the help of Venn diagram we can This is your homework. Chalo. A intersection B can be derived from A minus B. So what is A minus B? All the things in A but not in B. Right? Again, that intermediate result will be again subtracted from A. So you will be getting the exact thing which is there in A intersection B. Right? So that means your intersection is derived one. It can be derived from difference. So difference is your fundamental, union is your fundamental, whereas your intersection, surprisingly, intersection is derived one. આપણને એમ થાય કે યુનિયન ફંડામેન્ટલ છે તો ઇન્ટરસેક્શન પણ ફંડામેન્ટલ હોઈ શકે, right? But surprisingly it is not. The set difference and union is fundamental, whereas difference is derived. Anyways, so this is a fundamental operator. This is exactly your selection operator is exactly same as your where clause. Retrieve the rows and tuples based on the condition. Symbol is sigma, and these are the operators you can use along with your selection. Similarly, project operator, again it is unary, fundamental, same as select in SQL. Retrieve one or more columns from a relation. Symbol is pi. And what is union and intersection and everything? Binary operator, fundamental. Union is, symbol is this, combines the tuples of both the relations, but it removes the duplicate values. Clear? Similarly, intersection, the things which are in both. Difference, whichever the things which is in A but not in. All clear so far? Right. Do remember these 5 notations very, very properly. Tomorrow I want to start with the example of these things, and then we'll be moving on to the cross product and other notations. Let me take the attendance. Online student, is it clear from my side?
Yes, ma'am.
Please do revise
Yes,
and
ma'am.
come. It's very
Yes, ma'am.
attend your roll calls, everyone. Write P in the chat box if you are present. Roll number 1, 4, 5, 8, 9, 10, 14, 18, 20, 21, 23, 26, 20, 27, 29, 30. One thing before you complete the attendance. Next week, already I have informed A batch. Next week will be a review week for all the batches. That means I'll be going to review your Google Classroom, 2 practicals, and your Apex account as well. Also, I may ask anyone to explain any query which is part of practical 1 and 2. So before a week, I am giving you the instruction. So please be prepared. On the day of your review, don't tell me, madam, we are having a problem. Fine. Whatever problem you are having, just let me know in advance. If your problem is genuine, I'll consider. Okay. So Isha, your roll number is 29. Okay, 30, 31, 34, 39, 43, 44, 48, 49, 52, 56, 58, 60, 61, 62, 63, 64, 65, 71, 72, 74, 75, 76, 77, 78, 79, 82, 83, 84, 85, 87, 88, 91, 95, 97, 98, 99, 100,
Yes.
101, 102, 103, 104, 105, 106, 108, 109, 111, 112, 113, 114, 120, 123, 126, 127, 130. Okay, fine. So online student can leave. Yes, fine, Abhijit. Online student can leave. Wish you a very happy day. Take care and bye for now.